Hello everyone again to my YouTube channel. Today I will show you how we can implement a model in machine learning. So our dataset here is very small, just for demonstration. So as we see here, we have three columns. The first one is country. The second one is GDP per capita. Okay, and the third one and the goal it's goal or target column is life satisfaction. So our goal here is to predict the life satisfaction index based on the single column we have here is GDP per capita. So I will show you the big steps we have when we try to building any or work in the any project of these science. So let's start with this project. So our model here, as we see, is life satisfaction is equal to theta 0 plus theta 1 times GDP per capita. So as I said before, this model is based on a single column. Here is GDP per capita. It's a linear problem, okay, or is a regression problem. Uh, this problem here we can classify it, or we can consider it like the first type of machine learning, supervised machine learning. Obviously, is a regression problem. That's what we can see here. After, okay, well, so the first step here is to import our packages, all the packages we need to build in. Uh, it's the pandas. Our first one is to import pandas. These pandas give us the ability to read our data. The second one here is to import matplotlib for visualization. Matplotlib plot as DLT for visualization. We can also import numpy package. It's very important one because that's for conversion the structure to consider it like array, for example, or if we want to reshape our data, we need to apply this package by pay. We can also import Seaborn. I will show you what is the Seaborn. Import Seaborn. So for this package of Seaborn, of course, it's also a tool for visualization and depend on visualization of statistics. When we try to detect, for example, outliers or to see the distribution of any variable, we should use Seaborn. Also, its famous one is very strong. Consider it as SNS. Okay, and also we need to import like image for show you images. Okay, what what like what image image as some alias in the image, the image, and also I will import Scikit-Learn package, and it's a very famous package in Python. Scikit-Learn is for importing our machine learning avoiding this high volume of this package, just I will specify what is the algorithm I want to import. So from Skiller dot linear model import linear regular iteration. Okay. Uh, so maybe all the package I need in this project. Uh, run so run on this package maybe taking a few time. Well, so what I did before in this project, we were working in this small model of prediction. Uh, so our goal here is to predict this life satisfaction based on this GDP per capita. And here in this kind of program, of course, the goal here is to find the best parameters. This, what is the value we can give for this theta 0, and what is the best value for theta 1. The best parameters, this is our goal here. And to do this in this kind of problem of regression problem, we have something called cost function. The cost function does is to is the value between the predicted value and the old one or the exist one, because as I did before, this kind of machine learning, supervised machine learning. So for our model to detect or find the pattern, we should give the labels and the values both. Okay, what I see. Okay, so just will explain more. Well, so the next step here is to read or to load our data. Okay, the next step is load our data here. So adding so as I did before here, the list or the first step here is to load our data. I will create a variable called df, for example. Then I will call the package of pandas. Then read. So read CSV because CSV. So this extension or this formula we have with this data, it's CSV. So for this reason, I call this function of read CSV. Of course, we have a lot of functions to read our data. I discussed that before in last or the previous sessions. If anyone interested to discover more of these functions, you can go in the playlist of pandas and see deeply how we can work with these functions. So in this case, our data it's called here it's life. Okay, life, life happy. Dot see our data. So we will call this function of head just to see the top 5 records with this function of head. Okay, well, this is our data. Okay, it's contained with 3 columns and 33 records. So, but with this function of head, you can just read by default 5 first record. Okay, so let's continue. So the next step here is to discover data type of columns, because that is very important in our model. All the data or all inputted data in our model, each should will be a numerical type, float or integer. So Python, of course, or pandas basically provide for us famous functions called info. Give us a lot of information about our columns. That's what info. Okay, to see all data type we have inside of these columns. I can see here. Wow. Yeah. So here in the country we have object. So everything in Python is considered as object by default. And then to change data type, we have a lot of functions or a lot of strategies to convert this data type. So in our example, what is important here is to see GDP per capita is float one, and also for life satisfaction. That's okay. That means we have no problem to continue. Okay. And the next step here is to prepare our data. Okay. Prepare our data here. I will add in a new cell and I will dash it and list it. So prepare our data. Okay. I will hereby it's a convention of community of the science. We have big X like that, and they will call it everything they want, but here, so just with convention, okay? So I have this variable called X equal to what? Equal to np dot array. So for this reason, I use this package of numpy as I did before, because I should reshape our data because we have small one, and as I did before in the previous sessions in machine learning. I work with PyTorch, and I tell you about vectors and matrix. Everything in the end in the science and machine learning is a matrix and vectors. So for the reason I import this package of NumPy, and they will have now this df independent variable that is called independent variable x content always independent variable. So in this case, I will GDP okay, per capita. So GDP per capita, and I need to reshape our data. So to avoid an error of dimensions of our shape, okay. Well, I will add in there shape. Sorry, I will add in the point here. Shape shape one, and we have the target in p dot array df. This is the target. Okay, now we prepare. We store uh, independent variable. So in this case, we have just one column or one variable or one feature, and we have the goal is to predict the life satisfaction. As I did before, it's a regression problem. It's not classification. Okay. So let's continue. Now I will show you visually. Okay. I will visualize this data. I will okay. Skip of visualization. We call df dot this attribute kind, what kind of plotting I want. So in this case, I want scatter because we have two variables, and we know this technique of scale, of course, we use it when we have two variables, and based on the scatter, I will discover the pattern of data. If we have strong relationship or weak relationship, that's depends, of course. And so based on this chip or this pattern, we can discover what kind of algorithms can work with. Maybe you can have exponential or logarithmic or cubic function, or so that's depend, of course, or linear or whatever. Okay. Here in this case, we passed for this line scatter, and I will add in our variables. So in this case, we have GDP for capita for X. Yeah, we have GDP per capita, and also for Y or the goal one, we have life satisfaction. Okay, so we have life satisfaction, and for now we run and see our data here. Okay, let's take in a few times, of course, before here. Okay, well, so this is the point we have here with scatter with scatter visualization. So we have all this point here in this plan. GDP per capita in x-axis, and y-axis we have an index of life satisfaction. So as we see here, we have some relationship maybe. Okay, and we have this outlier 2 point we have here uh, with the high GDP per capita, but life or index or the value of life satisfaction is low. Okay, but it's okay. Maybe we have other variables contribute to determine this life satisfaction. Okay, here I built in this model just based on one variable is GDP per capita. Okay, we have other variables we can add it. Maybe I don't know. Okay, by healthcare maybe, or we have other or indexes of psychology, for example. We have a lot of variables can contribute to determine this life satisfaction index. Okay, let's continue. Well, so here also we can use SNS or Seaborn, as I did before, because the goal here, when facing this kind of problem, the goal behind this equation of life satisfaction equal theta 0 plus theta 1 times GDP per capita in this case is to determine the baseline. The baseline does mean, as I said before, we need to optimize or minimize the value of errors between the two parameters, the target or the predicted one. Okay, just I will show you something here. Where is Y? Okay, so we have, this is the target. Okay, we have the predicted one. The cost function, we need to minimize the errors. That means the difference between Y and Y hat, the predicted one, is should be less. At this time, we can find the best parameters for this equation, the baseline. Okay, so here with this Seaborn, I will show you now. Let me add in new cell. So using Seaborn here. Okay, here we have CNS as alias of Seaborn, of course, and we have a rig plot, and we have x equal to GD, so GDP per capita. We have also y equal to, in this case, is life section. Okay, life section. Okay, and we have the third one is optional, is data equal to df, because we called both variables x and y on df. Data is df. Okay, so let's run and see here what's happening. Okay, I want just check this package of Seaborn, if I give it the alias or not. Yeah, we are Seaborn is initial. So okay, it's return ourselves. Check. Yeah, okay. So here, as we see all, you see the line we have here is not the best line, just its representation, okay, of this line, and we have this scatter, and we have this line. So the goal of the cost function is to measure the difference between this line. Is if we consider it the best one, we need to measure this distance between all this point and the line here. And the best one, of course, should be have the least distance of all these points. And I will show you now one picture to understand deeply what I tried to explain. Okay, give me a second. I will add in a seal here. Okay, and they will read some images here to show you. Well, I will okay, I will dash in this command to show the pages. Read image, for example, equal to in page image two. I will call it in alias. Then I will output the image. PLT in show. Okay, I will show you. So about Morocco, because we see So here in this dataset, of course, we have Morocco here with the GDP and with life satisfaction with 5.06. Okay, we have error here. Morocco, no, MG. Okay, we'll run it again. So our goal here is to find the baseline. Okay, as I did before, I will show you. Let me show you how. So here, I don't know if it's clear or not. Just it's I will try to show you the position of Morocco here with this index. Okay, but important one here is I will add in a new gap code and pass it in this new cell just for not wasting the time. Okay, we have here lines maybe. Yeah, it's lines. Okay, so if I run it now, I will show you images show how we're gonna find the baseline. Here, just so we're here in these images as I showed you before. We have skater and we have the lines here. Okay, so each time this theta zero taking a value and we draw it. So in this case, for example, with the blue one, we have theta zero equal to 4, and this 4 in this index of life satisfaction is passed here. Okay, and we have slope, slope of this line. I will show you the parameters of slope and coefficient, and I will show you what is the best combination here in this case. Okay, and we have the green one. We have in this case theta zero equal to 8 and past 8 here, and we have the slope is a negative one. As we see here, we have minus 5 times 10 power minus 5. Okay, and the latest one here with the green with the red color, we have slope here equal to 0. That means pass here in the origin of this graph. Now we have theta 1 here taking 2 as a slope. Okay, so here in these three possible line, we want to find what is the best one. As I said before, based on this cost function, we need to optimize or to find the minimum error between all these blue points scatter and the line. What is the minimum distance? That is what the algorithms work or try to do. When we found the pattern, when we found the pattern, so at this time we have the ability to predict or make an interpretation. Okay, so let's continue here. Well, the most important phase now is to select our model. Select our model. Okay, let's I wish these things is clear, but I will make the link for GitHub for everyone interested to discover more to load this file. Anyway, I will now this in this step I need to select in the model. Select the model. Okay. So in this case, as I said before, we work on the problem of regression. So I will create a variable called model equal to Scikit-Learn. So Scikit-Learn. So dot linear model dot linear regression. Linear regression. Okay. So here, without changing the upper parameters, I will just take it by default. So in the next sessions, I will go deeply and try to find the upper parameter tuning. Linear regression. Okay, here we go. Uh, Scikit-Learn. Okay. So if I run it, we have problem of okay. Try to enter. Okay. So we'll run it again. Let's see now. If I go, okay, okay, now it's working. Okay, now we import our package, or sorry, we import our model. So in this case, we work with linear regression. As I said before, this problem is regression. It's a regression problem. We need to import this model. So the next one is to train our model. We have, or in this case, okay. So in this case, we will be using a fit function. We have three functions. We have transform, and we have fit, and we have fit transform. In this case, I will just work with fit functions. Just I will to have a values of each point have in dataset with the me. Okay, I will discuss deeply that. Okay, no problem. It's okay if someone will understand what I try to show you. We have, so we have model dot fit function. We need to train this model with parameters x as I prepared before and y. Okay, we prepare these two variables x and y, and I will run now. X not this x is need also to reshape and I will go to my model here to again. So not so now it's work. So the last phase is to make the prediction. So I will create a new one, call it X image walkthrough. So it's new variable. Doesn't mean here what's that? So based on this equation or this model we have, this new to find a new life satisfaction, I will give a value for this G per capita. If I trace randomly other country I don't have in this dataset, I will give it a new value here. Then based on this best line with these two parameters, I will found a life satisfaction. That's what I try to do now. Okay, so let's give in random values here. For example, is 22. So this is the GDP per capita for some countries. Okay, I don't know it, but what is important for me is to predict the index of happiness or life satisfaction. Okay, to do this, I will use the model as I trained before. I will call it model dot predict. We have this function predicts, and they will give. Uh, so if I run it, I will find values here. Okay. Okay. So life satisfaction of this country is 5.77. Okay, this is the index. When I have this new input with this value here, I will predict or I will forecast this new value of life satisfaction. That is what's called linear regression. So here it's a small and it's very weak model, of course, because we don't have the other variables. But when when we face into real problems, we can have more thousands maybe of variables. At this time, we need to find the best one. So let's show you what is the best parameters of theta 1 and theta 0. As I told before, we have two functions. So for slope, slope for slope of this function, it's called the model dot conf. Okay, run it. So this is the one. This is the best values for this one, for theta 1. Okay, for theta 1, the best value I found it here is maybe 2 point something like that. So based on this model here, the best value for this one, for this parameter theta 1, this is here. Okay, is 2 point something like that. Okay, I will add in a new cell here for intercept. So for intercept, just I will write in model dot intercept. Okay, enter. If I run it again, okay, the best value for theta 0 is 5.13. So this is the best parameters. So the baseline when I have in this example is with these two values of 2.81 and 513. Okay, so I will add in this tutorial. Happy learning for everyone. See you next. Bye bye.